right, so on behalf of the OPWA, I'd like to thank everyone for joining us today for this presentation. OPWA, we're an organization of public works practitioners. We're a not-for-profit organization. We're one of 63 chapters of the American Public Works Association, with over 500 members in Ontario who are employed by governments, municipalities, consultants, utility companies, contractors, and suppliers. The way that we're set up, we have two branches, so one in the Niagara region, as well as the West Central branch, and in the Ottawa region, there's the Ottawa Valley branch. So again, we're the Ontario Public Works Association, and our mission statement is to connect the public works community. So that's what we offer for our members, so opportunities to connect through workshops, conferences, and social events. This series today is one of the OPWA Connects, which is a learning program to help connect membership with technical and educational resources. And we target holding these webinars monthly. So if you want to learn more about OPWA and how you can participate, we'd encourage you to reach out and look at joining our organization. After the presentation today, Brian will send you a survey, and if you're interested in providing your email address to learn more about our organization and events, we'd encourage you to do that. We have some exciting upcoming events, including the Ski and Snowboard Day, which is February 3rd at Osler Bluff. So that's in the Blue Mountain, Collingwood area, and it is a great day. The price is very fair. I think it's $79 for members and $99 for non-members. So again, that's a very exciting event that we have coming up, as well as our International Women's Day celebration, which is always very popular and well attended too. So again, if you're interested in learning more about OPWA or looking at starting a membership, we'd encourage you to provide your email address to the survey as it's reached out, and to also check us out on our website to learn a bit more about our organization. So for our webinar today, just a couple of housekeeping notes. All of your microphones have been muted and your cameras are off. We encourage you to ask questions. So if you have any questions for our panelists, please add them in the Q&A box throughout the webinar. At the end of the presentation, we'll go through the questions we've received with our hosts just review those questions. So our webinar today is about an hour, and it should be an exciting topic. So with that, I'm going to turn it over to MTE. So MTE Consultants is a multidisciplinary consulting firm of over 400 people, providing services in engineering, building science, land surveying, environmental science, and more. MTE was founded in 1985 in Southern Ontario, and they're proud to have helped shape the regions in which they work and live for over 3 decades, aligning with their clients to improve the communities of their friends, families, and neighbors. MTE has been directly involved with the design and construction of over 25 roundabouts in southwestern Ontario, primarily in the Waterloo region, but also Wellington, the County of Brant, City of London, County of Grey, and City of Peterborough. And with that, I'll turn it over to Dot Roga at FTE.
Good afternoon, everyone, and welcome to our webinar on roundabouts. I am Dot Roga, manager of the Municipal Division. And I'm joined by my colleagues, Nathan Dumering and Alec Hegarty. I will begin by giving you a little background on myself and then give my colleagues a moment to introduce themselves. So I've been in the business of municipal engineering for over 25 years, and I've managed the planning, design, and construction of roundabouts for the last 15 years. During my previous employment at the County of Wellington, between 1996 and 2004, I was responsible for designing improvements to many intersections, from a stop control condition to a signalized operation. And now many of those intersections are being considered for roundabouts as the merits of their function become more apparent. I started my career at MTE in 2006 on the Iron Needles Boulevard project in Kitchener-Waterloo, where in that phase, we constructed 3 roundabouts and then continued to construct 2 additional roundabouts, modify and revise one, and widen the corridor to 4 lanes over the coming years. So it was an exciting way to start my career here at MTE, and a very quick study on how roundabouts began. Now I'll ask Nathan to share a little background on himself, and then Alec.
Good afternoon. I'm Nathan Dimmering. I've joined MTE over 18 years ago, right out of college. I've been involved with over 20 roundabout projects. I started basically 15 years ago, starting to get involved with some of the roundabout projects around the region, and have been working on them ever since. This year we had 4 roundabouts go to construction, and we have several more in the different design stages. Over to you, Alec.
Hi, everyone. My name is Alec Hegarty. Just a little background about myself. I graduated from the University of Waterloo back in 2018. When I first graduated, I actually dabbled a little bit in highway design. And then pretty shortly after that, I was given a wonderful opportunity to work for MTE to pursue some roundabout design. I instantly fell in love with it. And so I'm thankful for the opportunity to share with you some of what I've learned.
So as an introduction, I'll let you know that our municipal division is based out of our flagship office in Kitchener within the region of Waterloo. And as you know, the region of Waterloo has been at the forefront of implementing roundabouts for intersection improvements in Ontario for a number of years. And we were very fortunate to develop and hone our skills in design and construction, and as well align our training and software choices with the region. So the region originally started out with Orston Roundabouts Canada doing their functional preliminary designs, which MTE then took through final design and construction on the projects we were awarded. And eventually the region became more confident in our analysis and design skills and have been awarding us projects that involve the full gamut from intersection control study planning through preliminary and final design and construction for roundabouts in the area. And today, we're going to talk to you about the experiences that we've had over the last number of years with the various types of roundabouts, and talk a little from the planning perspective, the design perspective, the construction, as well as maintenance. We have designed and constructed rural single lane roundabouts to primarily improve safety with low volumes. And we've also completed multi-lane roundabouts where traffic capacity improvement as well as safety improvements were required. And those corridors had volumes of over 50,000 vehicles a day. So I think, we can start off by just talking about the basics of a roundabout. What are the advantages? What do people see as the good points of having a roundabout? Well, there's a lot of increased safety. Predominantly, I think the increased safety is paramount. The increased intersection capacity is also a very important factor. And we do see a reduction in fuel consumption, emissions and noise, traffic calming, and community enhancement. Now, along with that, there's always disadvantages, especially in the urban environment. The larger space requirements for these roundabouts pose a problem. And a lot of times the intersections as they're built are built out around them. So buildings are built close to the property line, making it difficult to, put these types of intersections in place without full buyouts. And that's part of the higher upfront costs. So you're looking at mainly property and a lot of costs to manage the utilities that need to be relocated or improved as a result. One disadvantage that we've come across, and it is definitely something you can work with, is public education, where we're in an unfamiliar location. People that aren't used to driving roundabouts need to be taught how to drive roundabouts. And although it's very intuitive to us now, it does cause some problems for people because it's a change and they have to make judgments instead of following a red or a green. So they have to warm up to these things and take some time. Some locations can be very complex, and it just proves to be either too difficult or too costly to put in place. One of the other factors is pedestrians with disabilities. We've yet to come up with a solution that municipalities have bought into for managing pedestrian use, especially with sight impaired disabilities. So that's something that is always being considered, and hopefully we can work towards a better solution for that. And then some say it's not as user-friendly for cyclists. I guess it depends on what type of cyclist you are. The road warriors will drive on the road and go through the circle like a car. But others, if you have a bike lane, we ask that you come off the road and dismount your bike to cross at the pedestrian crossing and then go back on the road, or use multi-use trails that we usually provide to give bikes and pedestrians access through the roundabout. So talking about lower accident severity, you have to recognize that one of the biggest concerns we have with standard intersections is the right angle T in a collision. It's a deadly collision, and it causes a lot of fatalities on high speed, high volume roads, as well as rural roads where you can't judge speed very well, and you are in a position of getting out into the intersection and being hit at a 90-degree angle. The other is the high speed rear end collisions that are also proving to be deadly. Roundabouts virtually take those two off the books because you're not in a cross situation, you're in a circle. So you're going to get a lot of accidents, but they're generally failure to yield, front and rear quarter panel damage accidents, very little injury, if any at all. So then that just gives you an idea of why we choose them. And then we can start looking at the different types of roundabouts that we have come across in the last 15 years. And Nathan will bring us through discussing some of these roundabout types. As you can see, we have a wonderful collage about of the various ones we've done, which have included single lane, multi-lane, rural, neighborhood roundabouts, which are generally within a subdivision, and innovative roundabouts where we're trying to solve very intricate problems. So with that, I'll pass the presentation over to Nathan, and he can continue talking about the design.
Thanks, Dot. Since I'm willing to bet most of you, if not all of you, have had some experience with roundabouts, given their growing popularity in the province. For this presentation, we're going to focus on the various roundabout types rather than going in depth into all the intricate details of roundabout design. Single lane roundabouts are the most common roundabout design that we see. This is due to the fact that in many locations, traffic volumes only dictate the need for a single lane roundabout. And often in those cases, they're desired due to their safety performance and traffic calming properties. There are many different aspects to a roundabout design. I would argue the two key pieces are the traffic volumes and the geometric design, and I'll expand on those. We start our design by looking at the existing and future traffic volumes and turning movements to verify that a single lane roundabout will properly accommodate the projected volume. We do this by first projecting the roundabout flow sheet that takes the projected peak hour turning flows and evaluates the traffic looking at entering, circulating, and exiting volumes. This gives us a rough idea if a single lane roundabout is suitable for our location. A single lane roundabout can handle approximately 1,200 to 1,400 vehicles per hour of combined entry and circulating flow. If the volumes from the flow sheets are borderline, or if the volumes are disproportional to one leg over the other, we'll perform a capacity analysis and verify the projected level of service to verify that a single lane is the right solution and that it's going to work as desired when we get out in the field. For geometric design, the principles that we really abide by are speed management, path alignment, design vehicles, active transportation, and sight distance. amongst a few. In simple single lane roundabouts, speed management and path alignment are often easily controlled and verified using a fastest path analysis. Here you can see an example of a fastest path analysis, which maps out the fastest possible route a car can take through the roundabout. Like if he's a race car trying to get us through as fast as he can, using the curve radii along that fastest path, we then translate that to projected speeds. And our goal is to usually have entry speeds in and around 40 kilometers an hour or less, and the differential speed of a car entering versus a car circulating below 20 kilometers an hour. And we can tweak that with the geometry to try and get those desired speeds. Design vehicles are usually municipality dependent. Often we go with use a city bus being able to maneuver without mounting any curbs for rider comfort, as seen in this example. We'll then use a large transport truck being able to maneuver right turns without mounting curbs so that we don't end up with any load shifts on hard right turns. And then for trucks turning left, that they utilize the aid of the central island truck apron. And these are just a sample of some of the design details we go into when we're doing a roundabout design checks package and ensuring that we've got the right geometry for this location. So now that we have a design to build, how are we going to build it? One of the more challenging design considerations is the construction staging. We start with looking at the scope of work and are there deep sewers, utility relocates that require full closures? What are the detour options? Can we do a full closure or must local traffic be maintained? All of these factors play into a detailed construction staging design. As can be expected, the less traffic we can have within the construction zone, the more efficient the project will run. It's very important, and I can't highlight this enough, to identify as many utility conflicts prior to construction as possible. Last minute utility coordination can be extremely challenging and in some cases a bit of a nightmare. If there are any current concerns regarding any utilities, we highly recommend it pays dividends to do daylighting to verify location and depths and arrange any potential relocations as far in advance of construction as possible. This is a very important part of the construction. As far as maintenance goes, winter maintenance is relatively easy. Plow operators can circulate the roundabout for cleaning operations. They can mount the truck apron to perform the clearing to get the plow in the right position. And we haven't heard too many complaints from maintenance sides of winter maintenance sides of things. One of the things we do recommend for winter maintenance is a design feature is to use tapered bullnose transitions. This allows the plow to mount the curb if they get a little too close to splitter islands rather than causing damage to equipment as well as the curb itself. Another concerns for municipalities is the central island maintenance. We recommend the use of a wider 4-meter truck apron, which gives the room for a maintenance vehicle to park on the central island to perform the maintenance. We've had some municipalities choose to utilize turf stone pavers for parking maintenance vehicles, but this has an issue in that it requires the vehicles to back into circulating traffic when exiting. So we highly recommend using a wider truck apron. With a 4-meter apron, workers can park on the central island, exit their vehicles, and perform any maintenance without having to go into circulating traffic. We've had some municipalities also install water taps in the central island, though this has the potential to become a maintenance issue in and of itself. So going on to multi-lanes, as in the previous example with single lanes, when we look at the traffic volumes, and if we find their borderline and start to perform a capacity analysis, we'll find that a single lane may not handle the projected volumes that we anticipate. Then we start looking at multi-lane roundabout options. Various configurations can exist depending on the site conditions. For example, we can have a dual lane circulatory for the entire roundabout, or as in the example shown here, we can have dual lanes in the east-west direction and single in the north-south. We can do quite a variety of lane designations. We can incorporate dedicated left turns, or in this example, we can incorporate right turn bypasses. All of this comes at a cost, more complexity for the driver, more challenges to get speed management, and larger crossings for the active transportation users. We found that over the years, when comparing a single lane versus a double lane or triple lane roundabout, the complexity for drivers increases exponentially, with drivers needing to figure out which lane to be in. We don't feel it's that complicated. When we go to public meetings, we try and reiterate to the public that when you're approaching a roundabout, it's the same as a signalized intersection. If you're turning right, stay in the right lane. If you're turning left, go to the left lane. But try as we might, there are always going to be those who violate lane designations. And so with that being said, there are usually higher accident rates at multi-lane roundabouts versus single lane. But as Dot mentioned at the beginning of the presentation, their severity is much less than that of a signalized intersection, and in many cases are property damage only collisions. For speed management, we focus much more on the approach alignment for multi-lane roundabouts. We often must tweak the geometry several times to get to the sweet spot of lower speeds, proper path alignment, and comfortable flow. As you can see in this example, we had a 2-lane roundabout, and when performing the fastest path, we had to do quite a number of tweaks to the entries and approaches to get the right balance of slower speeds and consistent flow. An additional geometric parameter that we look at for multi-lane roundabouts is called path overlap, which looks at the direction the 2 lanes are pointed when entering the roundabout, ensuring that drivers from the outside lane aren't directed to the inside lane of the roundabout. As you can see in these figures on the screen, poor curvature will end with cars going in towards the inside lane, and you end up with a collision just past the entry. So our goal is to get the right pathing. For construction with larger roundabouts, often there's more land area that we can work with when we're preparing our staging plans, which lends itself to more flexibility for maintaining traffic. That said, the reason we are installing a multi-lane roundabout is due to existing traffic volumes. So there will be inevitably be more significant construction-related traffic impacts. If it is at all possible to close all or at least some of the legs of the traffic, that will help with construction operations and the efficiency of the construction. Take the example shown here. We were planning to construct 2 large roundabouts, and the municipality wanted both completed in one construction year on a roadway that conveyed one of the intersections conveyed 60,000 vehicles per day under normal volumes. They wanted it also open prior to Oktoberfest, as one of the larger fest halls was just down the road. To accomplish this, they allowed the closure of one of the region's larger arterial roads, allowing us to construct a temporary bypass road, which allowed the construction of much of the roundabout area while maintaining some of the local traffic. As with a single lane roundabout, winter operations for multi-lanes are quite similar, except larger roundabouts require multiple passes, which may require more coordinated operations effort. I'd like to hand it off to Alec, who's going to talk to you about rural roundabouts.
Okay, so one of the reasons that I got very interested in roundabouts, and especially rural roundabouts, is when I first started my career as a co-op student, I was doing work for a municipality at a traffic signal department. And one day we got a call saying, oh, there was a collision. We have to go out and inspect the signals to see if they need repair. Think nothing of it, go out there. It turns out it was actually a T-bone case where the victim, unfortunately, was a mother of 3 who passed away. So ever since that day, I vowed to try my best to make everything as safe as possible whenever I do a design. So roundabouts were naturally a good fit for me. So the first thing I just wanted to go through, not to bring everyone down, so I'll try to bring everyone back up here, is to give you a couple of examples of a few rural roundabouts that we've designed over the years. So this first one being the Kossuth Road at Wellington Road 124 in Wellington County. As you can see, it was actually that southeast leg there is for future development. So it was quite a interesting design phase to keep into account and to work with the other consultant that's doing the site over there to ensure that the roundabout's going to connect to their road and everything's going to be hunky-dory there. The next would be Ament Line and Hergot Road in Wellesley. The need for this roundabout began when there was 2 separate fatal accidents that occurred at the intersection. So then MTE was then brought in to design a roundabout that would significantly improve sightlines and reduce the driver's speed entering the intersection in order to reduce the severity of these collisions. And finally is the one that I'm working on, which is the Gray Road 3 and Gray Road 4 in Gray County. It's actually quite an interesting project as well. We were given very tight property requirements in the Northwest. So basically we couldn't take any property from the Northwest. We needed to shift the central location of the roundabout in order to fit within our proposed limits. And at the same time, we needed to keep running iterations that would allow us to get the appropriate speeds throughout the movement without interfering with the Northwest corner at all. So quite a fun project to work on. So when it comes to a rural roundabout, the main concern would be of course, your collisions and the severity of them. So roundabouts are normally a good solution to a capacity and flow issue. In a rural situation, that's really not going to be your biggest concern. So basically, yeah, the biggest concern is going to be your collisions. So these are usually caused by high speeds and poor sight lines. Not only that, but when they are traditionally right angle collisions or head-on collisions, you get some catastrophic results. So as Dot mentioned earlier, we bring in roundabouts as they primarily only produce property damage collisions there. So now just to give a little bit more of a brief overview of the speeds. So the biggest concern at these rural intersections is the speeds that cars are traveling, which is even more vital at a two-way stop controlled intersection. And basically in these situations, there's special guidelines in order to get your approach speeds lower. And you got to produce proper radii in order to slow the cars down to a reasonable speed. Other things that help in these situations is proper signage. Usually in rural locations, you're higher speeds, like I said before. So you have bigger signs. You need to ensure that you have proper lighting and curbing to ensure traffic calming. And usually we have these go all the way out to the end of the splitter islands there, just to really get cars to slow down. So just to speak a little bit more on crash severity. So crash severity can be argued is the biggest reason to install a roundabout at a rural location. As mentioned earlier, the lack of gap judging and poor sight lines. Traditionally at these intersections, you get a lot of right angle and head-on collisions, which are known to cause fatalities or severe injury. With roundabouts, you're going to get people who don't understand how to use them correctly sometimes. That's just the way life works, unfortunately. But again, their mistakes are only going to lead to some side swipes, some rear endings, property damage stuff. So the better the roundabout is designed, the slower both cars will be traveling throughout the roundabout, which will minimize the impact of these collisions even further. And the final thing that we kind of worry about when designing them are the heavy vehicles. At a rural location, we've seen a lot of fun vehicles that can traverse them. So these can range from a horse and buggy out in the Waterloo area. If you've ever been out here, there's quite a few horse and buggies, and all the way to the giant farm combines. So in a rural roundabout, we account for this by trying to produce a larger diameter circle that will allow trucks, combines, you name it, travel through the roundabout with no issue. And again, as Dot mentioned earlier, we like to widen the inner island there so that if a maintenance crew needs to go out there, they can park the car on the central island, open their door, and they don't need to impact circulating traffic. So now in terms of construction, when it comes to constructing a rural roundabout, much like any rural road, you don't really run into too many utility conflicts. Of course, you're going to have a few, but it's not like you're dealing with buildings on every single corner and stuff like that. So you get a little bit more space to design it. The biggest issue that you usually face is the staging. So in an urban area where there is plenty of opportunity for detour, you have the options to close a stretch down. And if they take a kilometer, 500-meter detour, they're going to complain, but it won't be as loud as in a rural location where your connecting road might be 2 kilometers away, give or take. And so you can't really shut down a road. So in order to do that, you have to keep traffic moving in all directions. Usually it involves the use of night work. Usually it involves the use of flagging operations, temporary asphalt to move people over. We actually have a great contract administrator who's constructed so many roundabouts that I'm just glad he works with us, because then I can ask him some questions whenever I get a little stuck. So the benefit of having a roundabout in a rural location is the maintenance. So the roundabouts are fully operational. If a power outage occurs, you don't have to worry about the traffic signals going out and sending a maintenance crew out into the middle of nowhere to get it done. Snow removal vehicles, like we said before, we designed for them to be able to not only traverse the roundabout, but exit and enter. They don't have to worry about the curbs too much. We put the little taper in. And usually a more experienced snowplow driver will know how to operate it. But say a newer one, it takes a couple passes and then they'll get it right away once it's part of their route. And the inner island, especially when it comes to the plant work in there, which sometimes we do, sometimes we have to ship that off to a landscape architect. It usually depends on the municipality doing it. But for that, when it's up to us, we like to put in native drought resistant plants. Requires very few maintenance crews. And like I said, native drought resistant, the plants will survive not only in the climate, but also you give them a big water when you plant them, and usually they can survive off of what nature provides them. And finally, just to give you a little bit of a number here. So the average rural roundabout single lane is primarily going to cost about $1.1 million, and that's going to include your design and construction costs. Of course, this number is going to change based on multi-lane construction, how intense the storm design is, and if a lot of utility relocations are required, sorry. And I believe that brings us back to Nathan.
Thanks, Alec. I'm just going to touch a little bit here on neighborhood roundabouts. Neighborhood roundabouts can take many forms, from small-scale single-lane roundabouts, such as this one here, down to mini roundabouts, which can take the place of a four-way stop intersection. They can take on a minimalist style or have grand aesthetics with public art. For these roundabouts, volume is rarely the issue, but more we're looking for traffic calming and aesthetics. And these designs vary depending on the land availability and the vision for the surrounding area. For example, in the city of Vancouver, they were looking for traffic calming features and installed a number of small circulatories to replace four-way intersections, and worked with neighboring residents and organizations to maintain the plantings within them. So it's just one option to try and, provide a bit of traffic calming and a different aesthetic to a neighborhood. In the city of Kitchener, they installed a mini roundabout to replace a three-way stop and utilized a fully mountable central island to achieve slower speeds, smoother traffic flow, while also allowing buses and trucks the ability to maneuver over the island if they desire. We've been working with a local developer for a subdivision, and they took the vision of using roundabouts as a neighborhood focal point. They introduced raised crossings with rapid flashing beacons. They did this in consultation with the town, the city of Cambridge, actually, as a bit of a pilot. They wanted to see how this works to have these raised crossings at a roundabout. That same developer in that roundabout is going to be doing quite an elaborate central island landscape as an entrance feature to the subdivision. So there's a wide variety of options and ideas that can be applied with neighborhood roundabouts. Often these roundabouts are built as part of a subdivision, and in those cases, obviously, traffic's a non-issue. In cases where they are being retrofitted, if they're in local areas, often there's a lot of alternative roads that can be used, and so full closures are easily achieved, and which helps expedite the construction. Depending how elaborate the construction is, often they don't take actually that much time compared to a traditional full single lane roundabout. One thing that we want to highlight for maintenance, it's important that municipalities understand what it takes to do the maintenance for local roundabouts. We have a neighborhood roundabout that we're working on that's actually under construction right now. And unfortunately, the operations department wasn't consulted during the design process, and during construction, when they saw the design, acknowledged that they didn't have the right plowing equipment to clear. So in this design, they were proposing on the one leg, which was going to have quite a high speed approach, that they were going to put in raised pedestrian crossings. Unfortunately, they felt they didn't have the equipment to plow that properly. So now we're working on adding a bit of an entrance curvature so that we can get cars slowed down before that pedestrian crossing into that roundabout. So I just wanted to highlight that it's important that when you're putting in those neighborhood roundabouts that we look at all the different maintenance requirements. Now I'd like to hand the presentation back to Dot, who's going to look at a few unique roundabout applications.
Thanks, Nathan. The first one I want to show you is a rural intersection in North Waterloo called Crowsfoot Corners, and you can see why. But the main through road is quite steep, and the two roads coming out to it come down grade to it. So there's been quite a few issues with sight lines a lot of accidents. And so we were hired to look at what we could do in terms of a roundabout. Now, I believe that Orston Roundabouts actually did the functional design on this because it was a unique animal in itself. And you can see from the proposed design that we came up with, quite a bit of impact to the top of the circle, to the property beyond it. Again, farm fields, steep slopes down to the field. Going to be a costly event to bring in material. But what we did instead was design the grade change along here and reprofile the road. So we cut about 1 meter out of the road. In that way we have not only the ability to use that material, but it also improved the sight lines for all the legs coming into it. This project is currently on hold with the region right now. And in the interim, they've put in signals just to manage the accidents until they proceed with this design again. The next one I wasn't involved with, but a colleague of mine here at MTE was. This is the Grand River and the Bridgeport Bridge over the river. And you can see how close that roundabout is to that bridge. The next slide shows where we are actually coming off the bridge and immediately entering into a roundabout. It has unique lane designations, and it's a very, very busy road. It used to queue quite heavily on Lancaster, and queues are basically gone now that they've managed the capacity so well with the lane designations of this roundabout. And this one was a pilot project that the city of Kitchener asked us to assist them with. This was an existing roundabout that we had constructed several years ago, Huron Road and Strasbourg Road in Kitchener. And in the top right of the intersection is a high school. And at the south, the Strasbourg Road South was poised for major development. So we were looking at, okay, cyclists and pedestrians as a priority. So this is a modified roundabout, adding a cycle path around the center of the roundabout. Because it was a retrofit, obviously there were some challenges. We were able to use some of the existing multi-use trail, and then we modified just the way that the crossing of the splitter island is. So we split it between pedestrians and cyclists. Now, cyclists do not have the right of way on this, pedestrians do. So pedestrians, you are by law to stop for pedestrians if they indicate they want to cross, but cyclists have to wait and clear traffic. This is a bit of a challenge, and it hasn't, this kind of concept has not been bought into by the region or other various municipalities because the Highway Traffic Act doesn't support the cyclists having the right of way. And although these work in very high cyclist use countries in Northern Europe and in Sweden and Denmark, they don't do so well here yet. So it's a challenge. It's another way that we look at the innovation that can be applied to intersections, and depending on the municipality and how they want to proceed, you can solve a lot of problems with these roundabouts. So I think that concludes our presentation, and we've got plenty of time for some questions and answers. If you Trisha, are you going to be presenting the questions, or how should we?
Yeah, absolutely. So thanks so much, Dot, Nathan, Alex, for your presentation. If you have any questions, please just add them to the Q&A portion or the chat portion, and we'll go through them. So it has been asked if there will be a PowerPoint after the presentation. We are recording the session, and it will likely be available on our webpage. If you would like the PowerPoint, you should email MTE at these email addresses here to ask for that. One of the questions that we have, Dot, is what communication is given in advance of a roundabout being installed to teach people how to behave in them, or just kind of to educate, inform the public regarding a new roundabout?
So to date, again, being that we're in the region of Waterloo, they added a good presentation and learning tool on their website. That is where we direct people to go look and see how to use a roundabout. It's a great graphic. It tells you, it shows some animation, and that helps. We try to put roundabout ahead signs in advance as well. And when we do our public information centers and our information packages that go out to the general traveling public in that area, we highlight some of these items in that package and are open to discussing in a virtual or in-person public consultation center.
Okay, great. Another question we have is, can you speak to the reduction in collisions for the locations that you highlighted, or how successful were they in terms of reducing collisions?
Yes, so I don't have collision data to share, but I know from speaking with my clients and colleagues over the years, it is extremely obvious that there are no fatalities and no very serious intersection accidents on any of the roundabouts that we have built. There wasn't an incident with a pedestrian, but honestly, it wasn't of no fault and proven to be no fault of anyone other than the person stepping off the curb looking into a phone. So those things we can't manage. But generally speaking, we have seen quite a significant reduction in serious accidents.
Okay, great. Another question we have are what your thoughts are regarding the placement of a centerpiece. So I think Nathan touched on those feature centerpieces in the island, or should those in general be avoided?
That's a good question. So the roundabout guides will all recommend avoiding those kinds of things. I know in the States, it's a very popular thing to put in a lot of art. And as I actually presented in the neighborhood section, there are some being put in. It's up to the municipality. Often, at least on high volume roads, we recommend sticking with just plantings and trees, small caliper trees, that if you end up with an errant vehicle, and believe me, we have photos of local roundabouts where someone just drives right through the middle of them, you avoid serious injury. If you start putting hard objects in the middle, that is a potential injury, collision. That said, it's very, very, very rare. So in the case of the local developer, I kind of gave the position of it's not highly recommended, but it's if the developer and the city were comfortable with it, which they were, they're going ahead with that. But often it's not highly recommended, but it is an option.
Okay, great. Another question we have is, what would your preferred design solution be for sewers and water mains within the roadway, so within the roundabout?
Yeah, I can take that one too. Yeah, so as far as water main, well, we have one project actually that got constructed this year. I believe it had a 900 diameter water main going through it. We just recommend having any access maintenance holes. It had a air release chamber, I believe. We actually, in that case, shifted the center of the roundabout so that the chamber would be within the truck apron and the maintenance apron, so that any maintenance that had to happen in that chamber could be done outside of the circulatory. So we try to keep any chambers, water or manholes outside of the circulatory. As far as stormwater, often we try to have, if it's a double lane roundabout, we'll have a slight crown, we'll have a catch basin in the central island. Aside from that, it's all going to be sheeting away from the central island and or from the roundabout. And often we'll try to put catch basins prior to the pedestrian crossings.
Okay, great. I think related to that is what do traffic controls look like for underground utility work for maintenance? So how would that be impact the traveling capacity?
Yeah, that's a good question. So, and I think I saw somewhere on the chat too, someone was asking about book 7. I'm not fully aware or up to date as to what exactly the official book 7 maintenance activities would look like. What we've seen is that they'll put a bit of a construction or working ahead, kind of to warning drivers approaching the roundabout, and then they'll just be on the central island if they can be without outside of traffic. If it's a multi-lane roundabout, if they have to close the central island lane, that would add a bit of a complexity. The other side of that too is that if you have large trucks, if it's a single lane, if there's a large truck, that may become a bit of a challenge in them navigating if you're on the central island. But again, those maintenance activities are very rare, or not as common, and depending on the volumes, you should be able to make it work.
Can I also
Okay,
add that the region specifically and other municipalities as well, when we're doing the utility review during design, we will often ask Bell, Rogers, Gas to wrap their plant around and down the side street and back up around so that nothing is going through the center of the roundabout, which would then decrease the need to go into the circle to do any work. So we often ask them to move their plant out of the circulatory road.
okay, thanks. Yeah, we have a lot of questions coming in, so we'll keep going. Which again, I think goes to the interest that we have in this topic. So one of the questions, are there best practices around sight lines through or around the island, i.e. ability to see cars coming around the circle?
Yes, there's I think a whole chapter in the manuals about sight lines and sight distance and that kind of stuff. As far as the question specifically in the roundabout, the goal, and a lot of people do ask, why do we put in all the plantings in the middle of the roundabout? I can't see anything. And actually that's done on purpose. We want people strictly to be looking to their left. What cars are coming? Do I have enough room to yield? Otherwise, give her, for lack of a better term. And so, yeah, we don't want people to be able to see all the way across the roundabout, because we end up with very frustrated drivers when you get a really tentative driver that stops and says, oh, someone might be coming in on the other side. We just want them looking to the left. And so we'll actually design the sight distance to try and get around that. We do also, as approaching, we have sight distances that we calculate approaching the roundabout, how far to the left we need to see. And we'll actually plot, in our design checks, we'll plot a diagram that shows shades where all the different sight distances are for a roundabout design.
Okay, great. I didn't know that. That's really interesting. Another question we have, what is the impact of property costs when designing a roundabout?
Well, that one is wide open. It really depends on where you are. We attempted to rebuild and add capacity to a very busy roundabout at Iron Needles and Herb Street in Waterloo. But we were limited and had to add bypass right turn lanes and do our best with what we had, because there were 4 fully built out corners. So there was not the ability to buy those out without incurring an extremely high cost. So, you know, we've been asking municipalities to change the way that they plan to have buildings built next to their high volume corridors so that we have some ability to expand them. So yeah, that could be no money to a lot of money. It's really hard to answer that question because it's so varied.
Okay, thanks. Another question is, what software do you use for design?
Good question. So as far as doing capacity analysis, we use Arcady, which is what the local Region Waterloo likes to see. And then for the roundabout geometry itself, we actually, we do it by hand. I know there is Taurus software out there that can help with some of that. but right now we prefer to kind of use the geometric basics and go with that.
Great. Another question is, what is the ideal plow vehicle for mini roundabouts? Are they required to be able to turn the radius, or do they plow right over the center island? And that might have been answered later in your presentation.
Yeah, I don't know if I have a good answer for that. I'd say probably with mini roundabouts, you need a bit of a smaller radius vehicle that can plow them. I think in the case of the neighborhood roundabout that I was mentioning there, I think they were concerned they didn't have a vehicle that had a plow that could traverse a mountable or a raised pedestrian crossing. So I think they wanted a plow that could probably turn its blade so that they could go up the crossing and make sure they cleared all the snow from the pedestrian crossing, whereas the angled blades were going to just miss quite a bit of clearing. But I'm guessing that was the concern there.
Okay, great. Another question, does Book 7 show traffic control setups for working inside roundabouts?
I believe it does. I'd have to, if that person wants a bit more detail, I'd have to take that one offline and I can guide them to where the right resource is, but I believe it does.
Okay. Another question, is there a minimum distance between two multi-lane roundabouts to ensure cars have enough time to change lanes between them? So it says Ottawa and Homer Watson in Kitchener, for example.
Yeah, so I think we had about, what, 110 meters, Nathan, between those two roundabouts?
Yeah, it was very tight.
And we also in that project, which made it more complicated, is that we have highways, ramps coming on and off at either end of this double roundabout. So, oh, sorry, I just lost my thought. Oh, yeah, so there was some discussion and some modeling done about how much time would it take to get from one lane to the other. And we managed it fine with the 110. I don't know if there's a minimum that's published.
Yeah, and I'll add for that one, we also, because we were anticipating quite a bit of confusion, we had, you may see, we did a lot of overhead signage on this one to try and give drivers as much advance notice as to where they were going. And because of the on-ramps, even when they're approaching the first roundabout, it'll say, stay in this lane if you want to grab the next ramp access. So we really tried to put a focus on signage for that.
Okay, great. Another question we have, has there been any application of rumble bars prior to approaching a roundabout to further enhance the message to slow down?
Not that I'm aware of. I haven't seen it. The one thing I think is going to come online a little more is the raised pedestrian crossing. If they could do that in advance and manage the drainage, as well as have the right maintenance equipment in place, I think that's a good idea. I think they stopped using rumble strips as a rule most places. And I really can't tell you why they did that, but I haven't seen it being presented as an option yet.
So the one thing we've heard from some of our clients is they're getting rid of rumble strips because of the noise complaints they're getting from local residents. So yeah, I haven't seen it applied for a roundabout.
Great. Another question is, as we get more roundabouts constructed and more experiencing with them, have there been any change or shifts in design that might not be reflected in current design guidelines? And I think you might have touched on that with the pedestrian and bike crossing, eh?
Yes, and one of the tweaks we did early on was to move the pedestrian crossings further back from the circle so that we could accommodate a 12-meter section between the crossing and the circle, so you could get two cars in queue without backing up into the roundabout while pedestrians are crossing. Started as 6 meters and now we've gone to 12 meters. So that's one change. This is an ever evolving design process because we're constantly being presented with different obstacles or concerns. And with the help of our clients, we try to keep up with the changes.
Okay, great. Yeah, we have a few more questions on the pedestrian side. So one is that we understand pedestrian is viewed as priority, but must the pedestrian crossing be so close to the center of the roundabout? Could that be a bit further away to give cars a chance to exit before needing to stop?
Well, that's an interesting topic because people won't go out of their way to cross safer. They want the fastest path when they're walking. We attempted to do that at the Homer Watson block line roundabout where we had a large high school, 2,000 kids. And we had presentations in the school and we asked them, and we talked about, you know, putting a bridge over it. And well, that was AODA issues as well as, you know, what it could be used for. But you try to get somebody to walk from an intersection away from the intersection to cross and walk back to the intersection. You're just not going to get the compliance. So that's something we struggled with. We tried to push it back a little bit, but we try to line up our sidewalks and our crossings so that we're not pushing them too far out because they won't use them.
And if I can add a little bit to that as well, we are changing when the decision was made to push the crossings back from 6 to 12, it was a little bit controversial. And so part of the reason we did that was, and I think someone may have mentioned, when cars are exiting the roundabout, they have to make some quick decisions and all of a sudden look, oh, there's a pedestrian crossing coming. So that was one of the reasons we moved it back. But on the flip side, when we're looking at that fastest path analysis, one of the things we're looking at is once a car kind of reaches the apex of the roundabout, they start speeding up to exit. And so the further that pedestrian crossing is from the circulatory, also the faster and potentially higher speed incident there could be with a pedestrian. So there's a bit of a conflicting interest there as far as pedestrian safety.
Okay, great. I'll just mention that we're coming up to 1 o'clock now. We've continued to have a lot of these questions coming in, so we'll keep going on and answering these questions. If you do need to leave, we have our presenters' email addresses here, so if you have further questions, I'm sure they'd be happy if you reached out to them. So we'll just keep going for another few minutes to go through some more of these questions as they keep coming in. So one of them is, how are you typically treating pedestrian crossings on multi-lane roundabouts? So ground-mounted signs, RRFBs, etc. So again, I guess related to that pedestrian crossing.
Yeah, so right now, often we are just treating it similar to a single lane, to be honest. We are putting lots of advanced signage that the pedestrian crossing is coming up. We actually haven't done too many rapid flashing beacons because that does create some other conflicting issues as far as for free flow into the roundabout and such. So we've often been just dealing with the basic traffic pedestrian crossing, level 2 crossing per the TAC manual. I don't know if Dot has some more a bit about dealing with disabled crossers or.
Well, not really, but just the idea that not too long ago, we started adding this enhanced pedestrian signage. It used to be yield to pedestrians. Now it's stop for pedestrians. We give them a warning that there's a pedestrian crossing ahead. And then we have signs on either side of the approach saying, okay, this is the actual pedestrian crossing with arrows pointing to it. And then that's pretty much it. We just increased the signage at this point. Like I said, there's been some controversy around the rapid flashing beacons. I see the value in them, but it's difficult because if you train the public to look for these and then they go to other roundabouts that don't have them, then they don't think they have to stop. So there's a kind of a global thing. If you do it for one, you should do it for them all.
And I'll add too, with multi-lane roundabouts, the crossing distance is longer, but I'd argue if you were to compare to the size of signalized intersection you'd need there with turn lanes and such, the crossing distance would be much larger and the pedestrian conflicts with right turning vehicles, left turning vehicles would be way more. Whereas at a roundabout, you're still only looking one direction for cars until you get to the splitter island and then you can switch to the other direction. So while it is a longer crossing, I would still argue it's safer than at a signalized crossing.
Okay, great. Another question is, do you design the roundabout based on the peak hour or average daily counts?
Good question. So that's we go for the peak hour. So we'll do when we're doing our traffic flow sheets, or we're looking at the AM, in some cases midday and PM peak hours, and then projecting out 10, 20 years, depending on the municipality, and basing our design off that. So one thing we have been starting to do lately, so that we don't overbuild the roundabout, is maybe if during a certain peak hour, we might end up projecting a level of service other than A, we might live with that a little bit until the local area is built up a bit, because you also don't want to build a 2-lane roundabout when a single will do. It just creates that extra complexity.
Another question is, do you have an idea of how much increase in capacity comes from conversion from a traditional stop controlled intersection to roundabout? So is there a large difference between commercial settings?
I think I've seen numbers 30–40% increase in capacity in various large volume intersections.
Okay, great. Another question. Is clear zone requirement applicable at 4 corners of a roundabout?
Good question. So clear zone, well, when we're doing our site distance, we'll identify the areas that are required as far as for site visibility. And then as far as clear zone, I believe they're talking about the chamfer at the corner. Really with the roundabout edging the 3-meter trail or whatever pedestrians facilities you have, usually just beyond there is satisfactory for the site distance. So then it's up to the municipality how much they want to acquire and have for their grading and in some cases ditching.
Okay. For unique roundabout intersections and neighborhood settings, how would you design for residential driveways that might be near the roundabout or directly connected to inner circle or that?
Often we try to avoid that. We do end up with special cases where it's not ideal. We've been working on a functional where there might in the city of London where we're going to actually be building a face road, or what do they call it, a facing front street, to try and catch a few of the houses that would have been in the roundabout. We also have another design that Alec is working on where in the county of Brant, where I believe they have an access either coming right into the roundabout or just off the roundabout, and it's not desired, but it's not the end of the world. I don't know if Alec wants to talk a bit to that or.
Sure. Yeah. So basically, they come in directly, almost like a fourth leg. So there was some discussion going on with the homeowners and with the county if we wanted to give them almost like, I think Nathan might have mentioned it earlier, but like a little access road that they could drive along, take them outside of the roundabout. But at the end of the day, we decided that the fourth leg, essentially, little driveway entrance, was better. They could come out, go around the roundabout to go right, left, sorry, or they could just go right, or they could go straight. It's yeah.
And just to add to that, in some urban centers where we have driveways close, we do break the splitter island. We do break the splitter island on occasion to allow that movement, either left or left out of the driveway. We don't like to do it, but we've had to do that in the past, and we haven't had any issues with it because it's literally a residential house, so you're not having a traffic issue. It's just they have to pick their times to leave.
Okay, great. Another question is, you've indicated you undertake your geometry by hand. Could you clarify how you're determining grading requirements, particularly where new ditches are required?
Yep, good question. So I guess what I meant by hand was doing the geometry, the 2D plan view geometry. when we do get into the grading, and I should have mentioned that for software, I guess, we are using Civil 3D. So we'll do full alignments. We use corridors, which is Civil 3D's way of doing the grading. We'll look at the, especially in Alex's case with rural roundabouts, ditch designs, culverts, storm designs. We utilize Civil 3D to do all of that. But it was just the geometrics when we're doing it. We'll use do some of that kind of by hand in CAD.
Great. Another question is, how do you manage oversized vehicles without a mountable central island in a neighborhood traffic circle?
Good question. So in that last example, actually, where I had I can even pull it up here, where we had that neighborhood traffic circle that required a bit of redesign. This one in particular here, what we did in order to accommodate trucks in this example is we actually made all of the front of the splitter islands mountable. So and you can see we put in stamped concrete, but all the curbing is going to be mountable. We have the curb rising just before the pedestrian crossing, so that there is a noted location for the pedestrians to cross. But yeah, we've in order to accommodate, and in this case, this is right in the middle of a subdivision, so we don't anticipate too many large trucks. But you'll see we put the signage further away from the central island and put the yield sign only on the right side, just so that a truck could mount the splitter islands if required. Good question.
Great. Have there been any designs of bike or multi-use path mini roundabouts?
I know in Holland there have been. I'm not aware. I'm not aware of any here that have been done, but definitely in Europe there's lots of that going on. But I'm not aware of one here.
Okay, great. I think you might have touched on this, but the question is, as noted in the presentation, utility relocations are not a huge obstacle in rural roundabouts. However, in more congested urban environments, do the roundabout designs include designated utility corridors for required relocations, or are utilities relocated on a case-by-case basis?
Yeah, so I think that goes back to what I talked about, having Bell and Gas relocate out of the circle. So we don't designate a corridor for them. It is a case-by-case basis. And we have a project coming up that we're in the middle of design for right now, where there's a large Bell structure under the road. And instead of making them rip it all up and realign all of that, we're going to likely put in new conduit around the intersection. And when it does fail, then they can go into that new conduit that we've placed on their behalf, so that we don't have that conflict down the road. But yeah, as a rule, not a dedicated corridor, case by case.
Okay, great. Another question is, I see that the Transportation Association of Canada has released new design guidelines for roundabouts. Is there a Canadian course available that you know of for designers to learn about roundabout design?
There is. The Ontario Good Roads Association puts on one. And I actually believe, I don't know if it's been a while since they've had one with COVID, but I know there was actually a couple gentlemen from the region of Waterloo that were teaching that. But yeah, there is some out there.
Okay, great. And another question we have, can proposed sidewalks be about the roundabout, or is a grass boulevard a must?
Sorry, can you repeat that?
Yeah, sorry. It's, I think, asking about sidewalks around the roundabout versus grass boulevards.
Right. So we recommend having at least a little bit of grass boulevard, and that's for a couple of reasons. We need that grass boulevard. It's for snow storage. Often, because roundabouts are lit quite well, we want people to see it coming. We often have lighting poles in that boulevard, as well as just snow storage, and to get the pedestrians a little bit further. We have done some, I think more in rural areas, where we've done curb face sidewalk or curb face trail, where quite frankly we don't anticipate many pedestrians. because the pedestrian crossings at roundabouts are considered level 2 crossings, we do need to provide some form of pedestrian path if possible. Yeah, often we would definitely want some grass boulevard if possible.
Okay, great. All right, I think that brings us to the end of the questions. So obviously you can see just by the number of questions that so many people are interested in the topic and the presentation. And we definitely had a few comments about what a good presentation it was and how clear the PowerPoints were. So yeah, just on behalf of OPWA, I'd really like to thank Dot, Nathan, and Alec for their presentation today. And if you have any further questions or want to get in touch with MTE, again, their emails address were there, and we'd encourage you to reach out. And also to take a look at OPWA's website and about our upcoming events as well. Thank you all so much.
Thank you.